Hi, so welcome everyone to, I think, the last breakout session slot of the day. I hope you're having a good time so far and picked up some things. My name is Stephan Becker. I'm a senior system engineer at Netcentric, and we'll be talking about a bit of accelerating your AEM Author instances. Many times you have situations when you're at clients and it's a heavy used authoring systems when end users, editors are complaining that the author system feels slow or something is not working at all. We had quite an interesting situation at Daimler where for whatever reason they just got blank pages and nothing was working anymore. So it's a bit difficult sometimes to understand at first what does it mean fields, because in the beginning it's more or less just screaming and shouting and nothing is working anymore. So the best way to actually approach the topic is really with some analytical sense, trying to identify the area of the actual performance issue, drill down on this and analyze it, and don't forget the other components in the whole web stack, because when we're doing AEM, also on the author side, you have quite a lot of different components, from browser to CDN or even ISP in between. You have your caches and so on. We try to always create some kind of mitigation plan. I don't know who was in the session with Ferran Sabata earlier. Okay, perfect. I'll get to that topic later also, and then of course we want to solve the problem. So first things first, we need to aggregate some data on how to fix this. The initial point where we can look is actually for authoring systems is the request logs, because they will show us instantly where the slow request might be coming from, or what is actually slow and responding slowly. If you're otherwise having monitoring tools in place like New Relic or AppDynamics, those gather a lot of different metrics and they prepare these really well. So you can basically just go onto the dashboard and within seconds, maybe minutes, you can already see a possible bottleneck. And from our experience at Daimler, we use AppDynamics heavily to look at application performance. It's really one of the best solutions we have in place. And instead of digging through code, it's just so fast to figure out where a problem might be. So what can we really do? And this is really depending on what you found out or where you're actually seeing the issue. One thing we can always do is, of course, throwing more power at it. So especially when we're running in some cloud-based setups, we're using maybe AWS or we're using Azure, we can scale up the systems easily. So also Adobe Managed Services running on AWS, if there's some situation, we can talk with them. We can talk with them and scale up the instances for a specific size, for a specific time frame. For example, when we see performance issues, maybe in production, you're able to scale up a non-production system to the same, and then you can work on it. There's an interesting saying in German. It's the displacement can't be replaced by anything but with more displacement. And actually, this is also quite true for AEM, because if we throw more resources at it, to some extent, it will be faster. The first thing when we look at performance is always CPU performance. This is a large production instance from Daimler, where we have 16 cores in total. This is idling. I think I took the screenshot last night, and there was no activity on there. But on regular day-to-day use, especially if you have many replications running, you have many published systems with many replication agents, they will make heavy use of the multiple cores. So this really can make a difference there. Another topic is RAM, and memory is actually quite an interesting one. We'll get into a bit later also. This is the same production instance, and here you can see it's quite huge. We have 64 gigs in total, And this is also what I meant earlier. When you're looking at the performance issues, look at the full stack. Because you, at the top, see Java, which is actually the AEM, because it's running under CQ user. Right below it, it's actually the App Dynamics agent, which I figured out last night is consuming way too much. And then you have Apache running on the same server. So especially if you combine the different parts of the stack and run it on one system, you need to watch out that they don't take resources from each other. So the sizing part is a big topic. Last but not least is storage and I/O. AEM has always been a I/O-heavy application. I remember the days at UBS when they still had spinning disks and the system was just super slow. Finally, we got SSDs and it changed the world. And also, if you're running in the cloud on AWS or Azure, you can actually book I/O-specific storage. And the I/O on the storage in AWS also depends a bit on what instance sizes you use. And this is especially interesting because our segment store and data store of AEM is laying on disk. So there's a topic called memory mapping, which I'll explain shortly, but also the index is now with 6.3 automatically written to disk as a cache. So the faster your storage is there, the faster also lookups will go. So we come to sizing and tuning. This is the memory thrashing topic. It was actually discovered, I think, about a year ago, exactly at around this time. We had the problem at Daimler that when we were doing mass rollouts with multi-site manager and having many replications, many nodes being written or being read, that the system was just brutally slow. So what actually happens is that the tar segment, the tar files, which you have a specific number of, they get mapped into memory. And the problem is if your system memory is not big enough, it cannot map efficiently anymore. So what it will do is it will start paging these files from disk into memory and start doing this when it's looking for other segments. So this is something to look at and work around. Just had another issue last week where we had the same at Allianz, where the sizing was off and the performance problems they encountered were due to the memory thrashing. So this is an example on how to tune the instance size properly, focusing on the RAM bit mostly, focusing on resolving the memory thrashing. You can do a simple calculation. As I explained before, we run Apache on the same server. So here you can actually see we have a M4 large instance on the right with 8 gigs of RAM, a heap configured to 4 gigs. The OS might be consuming 2 gigs, Apache around 2 gigs or more, depending on how many processes launched. So we end up at a total usage of around 8 gigs. In most of the cases, your segment store will not be 0 gigs. So minimum usually when you're running anything is maybe around 5 to 10. So when it would need to start mapping this to memory, it can't do this efficiently anymore, so it would start paging. And here you can see with a larger instance size, the memory mapping will work properly because it could load the segment store basically into memory and improve the overall authoring performance quite a bit. We took some measurements, of course. This is a screenshot from App Dynamics where we're looking at the disk I/O. We had the time of the M4 X large instance and the time after with the 4X large instance. So 4X large is actually the instance sizes we're running in production for Daimler, for the author systems. And you can see that when the system was size smaller, it would mean it had to page a lot more, so disk I/O went up, overall performance went down. When we actually scaled up the instance, memory mapping was working performantly again, and the disk I/O dropped instantly. You definitely still have some heavy operations like backups if you're doing the hot backup to some volume on the side and so on. So this is something to keep in mind. Also the index, the copy on read, copy on write index cache, it's always on the disk there. So it comes down to really having a well-oiled machine, because it's not only CPU, RAM, and storage, but everything else around there is, as Michael showed this morning, the AMG. I have a BMW, but doesn't matter. The brakes matter as well, you know. The exterior matters as well. So we really need to look at all the different parts where we can tune the actual performance. So there's some AEM screws to check and adjust. The data store and segment store were not previously split with 6.0 to, I think, 6.3 on default. So you had to implement a configuration that the data store and the segment store is actually split into two different parts. If you don't do this, the problem exists that the data store is also inside of the tar files. So your tar files will just explode at some point. Tar compactions will become longer running, and also the data store garbage collection doesn't work so good. The real problem is also loading the even bigger tar files into memory becomes a problem. One way also to get rid of the data store completely on disk and reduce I/O impact there is if you're moving things into cloud storage. So you have the out-of-the-box Adobe AEM S3 data store connector, so you can configure it from the start. And especially if data store is not so active, then it can easily be moved off. We have a rule of thumb where we say that the heap size should not be more than 50 to 60% of the total system memory. The reason for this was initially that we discovered with 6.0 there's something going on in the background, that this memory mapping was happening, but we weren't sure yet what was going on. So this is really just a rule of thumb now, because the better calculation on how to size properly for performance is what I showed you before, making sure you have enough RAM that the segment store can be mapped properly. And also the copy on read and copy on write is now enabled per default. So this is something not to worry about anymore with 6.3, but also interesting to see how it works. There's some wiki pages on it which detail this specifically. So something we don't do too much on the authoring side is quite often the caching. And we do usually have a dispatcher in front, or actually a varnish. But in many cases, it's not used as much as we could. In Daimler, we're using time-stamped assets for almost everything, which allows us to cache everything, except some dynamic data. So this is really awesome because we have a huge cache even in front of the author system, and we can offload a lot of things which would impact end-user performance in that sense. So make use of it even in front of an author instance. If you're curious looking at our dispatcher configurations, I'm happy to send you the Git repo to take a look. Introduction of time-stamped assets. I don't know if this is being done in all projects, but I think in some we do, in some we don't. So I'm not the developer, unfortunately, but this is something we can talk to Thomas Hartmann about and look at it, or also Kadri. And configure the caching for the time-stamped assets, because we configure caching for that for 2 years. And if there's a new asset, there's a new timestamp, so you don't even need to invalidate your dispatcher cache or varnish or anything. So an interesting addition we did at Daimler initially for the retail project. This is a AEM setup where we are hosting 2,600 retailer websites worldwide. And the problem that we had is also that the end user, or not the end users, but the actual editors were spread across the globe. So to work around this, we actually added in CDN, so we're using Akamai for this. It's sometimes a bit difficult topic because, of course, if you have different edge servers around the globe, Your performance will increase amazingly, but it's really about the data storage that you have on those edge servers, because you're not in control of this. And if you have, for example, sensitive data or images, example, some new Mercedes model which is coming out, they already upload the images before on the authoring side, before activating the pages. So when they're using this, in theory, you could work around and gain access to the edge servers and to these assets. So it must be looked at what's really cacheable there. One way to work around this also is using a no private header, which you can send from the authoring side, which would enable caching on your browser, but basically disables caching on Akamai and on any proxies. Something to check, because not all proxies in between tend to honor it properly. So with this, it really improved the overall performance, because all the editors are spread across the globe. So the concern is still there, but that's still being discussed and evaluated. Something we also were working on in the past, I think 1 or 2 months, was actually tuning the asset loading behavior on the authoring side, because the culprit is really not necessarily on the server side anymore, but it's really about like browser performance. So something we did immediately, Akamai has it, many load balancers, for example in AWS have it, other CDNs have it too. You can terminate HTTP2 on those. So you don't need to implement HTTP2 on your Apache or in the backend, but you can terminate it on Akamai side, and it works amazingly. Ferran, as I explained already before, had a talk about this earlier, which is super interesting to look into, because it exactly touches on these points. gzip compression in Broadly. I don't know, has anyone heard of Broadly? Awesome, one person too. So Google is coming up with these Swiss names for compression methods. They have Broadly, they have Zopfli, and then there's Grützli coming out. So Broadly is quite interesting because it improves the compression quite a bit for JavaScript and CSS, only for those. And also Akamai is now running a beta where you can enable it on the Akamai side. You don't need to worry about it again on the server side. And we did some tests, and with files around 5.5 KB, we squeezed out down to 3.8. So it's not much, but the sum really makes it. And this is also a topic that Ferran touched on earlier, is really separate the client lib categories. So you don't load one huge file anymore. You load on demand for the different components. And this was actually the problem that we encountered with the blank pages on Daimler, which was really impacting performance and user interaction. They got a blank page because the browser couldn't handle their connections anymore properly. So this was solved with this, and now everything is running smoothly, even with editors sitting in Australia. So quick recap. This is what we're aiming for. It's always interesting because you tend to get the complaints, then it's fixed, and you never hear from the people again. But if you don't hear anything again after you fix the performance, that's okay too. Some takeaways. First topic to look into is really infrastructure sizing. Looking at how your AEM is behaving, how it's growing. You might need to look at this also during already a live state. So it's not just gone live and then nothing to worry about anymore, because the data store tends to grow. Maybe there's more rollouts, more sites, and so on. So this is something to check on periodically. The AEM sizing itself is also a big topic. Heap sizing must fit. And in addition, maintenance is also quite important. Like performing regular offline compactions reduces the segment stores, and due to this also the lookups are much faster. And workflows, we discovered quite an impact having way too many workflows in the system as well. General usage goes down the drain. So make sure workflow purging is active, version purging is active, cleaning out the regular stuff, because this will improve the performance there as well. Dispatcher and or varnish. In most cases, I think we're running the dispatcher, and UBS we're having the varnish in front, but I don't know on the authoring side. And CDN is really interesting to look into if you have a lot of end users, editors distributed around the globe, because this will make a huge difference for the actual performance. But keep in mind the topic about sensitive images and so on. HTTP 2 is super easy to enable. All the browsers basically support it. And it's really just a click. If you're using a CDN provider in front of your publish instances already, maybe it's worth to consider putting it even in front of the author instance. Disable the caching if it's a topic about the sensitive data, and just enable HTTP 2, or maybe you have a load balancer in front which you can use as well. And the loading behavior, this is really what saved us in the end. So it's a huge difference. Broadly, we're going to investigate more on it. So we're running some tests, and we'll see how that goes in the next 2 or 3 months. And maybe I'll write a blog post about it and see how it went. That's it. I'm through. Thanks.